This is experiment 6, calorimetry. This is in the calculations portion. We're going to calculate the specific heat capacity of a metal. On your calculations page, this should look familiar. You have your heat taken in by the metal. That's going to equal the heat given off by water. So it's going to have the negative sign. So our Q of our metal is going to be equal to the minus Q of water. So this is a heat exchange. Okay, so we're going to use MCAT for both sides. So for our Q metal, we're using the mass of the metal times the specific heat of the metal. But this is what we're trying to find, right? The specific heat of the metal. And then the delta T is T final minus 0 degrees C, because we put the coins in the freezer, equals the minus of our heat given off by the water, so that's the mass of water, times the specific heat of water, times the temperature change, T final minus T initial. Now taking a look at the data again. Now I'm going to redo this by the time you guys get the lab. We're going to make this one page each for table 2 and table 3, because there wasn't enough space. These take a little bit longer. So you're actually going to complete all of the times, but to give you an idea, so our T initial was 21, or mine was 21.8 degrees when I started, before I added the pennies, and then the T final, again, is the minimum. So it went from 21.8 degrees C, went down to 20.6, stayed, if you remember, stayed at 20.7 for a very long time, and then I just made sure that it rose, and it went up to 21. So the minimum here is our 21.6, so that's our T final. Okay, so now we're going to go ahead and plug everything in and solve for our specific heat. Now the mass of my metal, so the mass of the metal, as you saw in the data table, I had 50.02 grams of my pennies. Again, we're solving for the specific heat of the metal. And our T final, I showed you, was 20.6. And it was in the freezer, so it's 0 degrees. And then it's gonna, we won't want to forget our negative sign. There's the mass of the water next. So the mass of the water, I had 101.08 grams. The specific heat of water, which is 4.184, times that temperature change. So it was 20.6. And the initial temperature, again, was 21.8. Okay, so we're going to calculate these through. So I'm just going to, so this is just 20.6. So I'm just going to multiply that by 50.02. So 50.02 times 0.6. Okay, so here I get CS times, just one more time, 50.02 times 20.6, 1030.41, and this is going to be grams times Celsius. Notice there's 3 sig figs here when I multiply, so I'm going to put my line here, make sure I don't forget that, equals, and I'll do the other side, minus 1 times 4.184 minus 21.8. Okay, on this side, I get a positive 507.502, and let's look at the units. Celsius cancels, grams, so we're left with joules. Let's take a look at sig figs here. So this is about, it's a minus 1.2 degree change, so it's 2 sig figs. So I'm going to put my dash there for the sig figs. Okay, now to solve for our specific heat, I'm going to divide both sides. Forget my sign. By 1030. Okay, and then when I go to calculate this, I'm going to divide my 507 divided by 1030. Okay, I'm going to get 0.4925, and then that's going to be 2 sig figs. So your specific heats, we're called, need to have the 3 units, right? They have to have joules, gram, degrees C. And so here, that's our final answer. Okay, that's our final answer. And I've done this experiment before, and I got a similar value. It was actually a little bit lower than this. But depending on the metals that you used, you're going to get different specific heats. So in your post-lab questions, you're going to talk about the composition of your coin. You're going to look up the composition of your coin and determine an average if you use different coins together, like if you use the copper pennies plus some quarters or some nickels. Okay, so if you have any questions, please ask your professor, but that's how you're going to calculate the specific heat of your metal.